Hello everyone, welcome back to another video in this series of GridPro version 9 features. In today's video, we will dive into the new clamped nesting feature of GridPro version 9.0. Nesting in CFD meshing is a way to create a grid structure with high resolution in specific regions, while coarser grids in less critical areas. In GridPro, nesting refers to the block structure between the different regions of grid density, while allowing a smooth transition and maintaining one-to-one block connectivity. Nesting is needed to effectively handle multi-scale problems by providing local refinements where necessary without increasing the overall cell count excessively, thereby optimizing computational resources and reducing simulation time for the applications such as LES DNS simulations. The author Philippe Spallard describes the different flow regions in a domain, such as the Euler region, focus region, RANS region, departure region, etc. The significance of region-based grid resolution is also highlighted in this paper. In the given example of the nested mesh on a helicopter blade, the cell refinement varies with respect to the region of interest. Here, the LES region has highly resolved cells as compared to the Euler region. This nest grid is achieved using an overset mesh, which has non-conformal interfaces. Here is another example for flow past a 2D cylinder mesh. We can notice the three different grid refinement levels in the domain. This again is a nested mesh using an overset grid method. The use of nested grids is critical to the efficient use of limited computational resources. In the above examples, we notice that the smooth transition between the fine and coarse regions is missing, which gives rise in flow instability. GridPro's clamped nesting block structure ensures the smooth one-to-one block transition between these two regions. It also maintains unit aspect ratio cells in the refinement regions to prevent solution distortion, and the capability of the local refinement aids in the cell count optimization. You can refer to the blog article on GridPro's website on the two different nesting block structures, mainly called clamped nesting and triangular nesting. Let us explore the clamp nesting feature through an example. Here I have an axial turbine blade case for which I have a basic block structure. I would like to use clamp nesting tool and build a refined block structure closer to the blade as shown in the example image. The clamped nest feature is found in the edit section in the right hand side menu. We will use the forward nesting tool to achieve the refinement around the blade. I will select the second layer around the blade in group C1, which will be the high density group, and the immediate next layer in group C2, which will be the low density group. Also, we need to provide a group for the direction of the nest. Here I want to first execute the nesting vertically, so I will select a direction group in a vertical sheet in group C3. The refinement level is set to 1. It can be changed based on the required refinement. Click Apply. You can see the number of blocks in vertical direction are increased with the help of clamped nesting block structure. Similarly, select the outer layer of the nest in group C4. And the immediate next layer in group C5 for the low density and high density groups respectively. Now in this step, I want to have a refinement in horizontal direction. So in the direction group, I will select a corner sheet passing horizontally in C6 and select the respective inputs. Hitting apply gives us the nested topology, which has a refinement in both directions. Let's have a look at the grid. Taking a slice in the vertical and horizontal direction to the blade shows us the nested grid refinement structure that we have created. Hope this helps you understand one of the highly useful features in GridPro. Happy gridding!